all. Myself, Dr. Amita Asthana from Akgec, Ghaziabad. So here in this video lecture, this particular topic has been taken from the unit 1, that is Clipper, and it has been taken from the subject Fundamentals of Electronics Engineering, targeting the first year BTech students. So BTech students can take help of this particular lecture to understand the concept of the clippers. So here, what are the clippers? First of all, we should discuss the clippers are the circuit that have to ability to clip off some part of the any input waveform, any input signal, whereas it is not going to distort the particular signal, but it can just clip off some portion of the input waveform, whether it is sinusoidal or whatever is the form of the input waveform. It is consisting of one resistor and one diode, depending on the orientation of the diode. The clippers are of two types: positive clipper and negative clipper. Maybe the clippers are clipping of the upper portion of the waveform at the positive side, then it is a positive clipper, and if it is clipping the negative part of the waveform, then it can said be the negative clipper. So there are so many non-linear and linear components are in the clipper circuit. It has linear component like resistance, and it has non-linear component like diode. And there are basically a vast two types of categories of the clippers. First is the series, and second one is the parallel clipper. Then you have to first of all select between understand whether the question which has been given from the clipper topic, that it is of series clipper or the parallel clipper. See, there is a technique to find out it easily, that what if let's say one particular circuit is given like this, and here this positive and this particular is negative, you are giving the Vi input like this. Okay, if the output voltage is asked across the resistance, then it is known as the series clipper. See, here the output is being asked across the resistance R, then it is obviously the series clipper. And at a similar, in the same context, if let's say I interchange the position of the like this, let's say if the voltage is asked between the terminals of the diode D, then we say that it is a parallel clipper. So it is very easy to find out whether the clipper circuit has been given as a series clipper or the parallel clipper. So it is very simple. You can easily find out if the output is being taken across the diode, then it is called as parallel clipper, and if the output is being taken across the resistance, okay, then it is a series clipper. So here we can simply find out whether this particular is the series or parallel. This is a simple series clipper because the output has been asked across the resistance, right? Now we will find out how to obtain the particular output of this question. So we will discuss it first. Here, while this positive half cycle of the waveform, this diode is being connected like the N is here and P terminal of the diode is here. N is connected to the positive side, so it has been reversed bias. So when it is reverse bias case 1, when input voltage is greater than equal to 0, the diode is working like this. It is reverse diode. It's a ideal diode. So there would be no voltage because there would be no current. I is 0 across the resistance. So VO is equal to 0. Similarly, when the negative waveform is there, when the case 2, what is happening in case 2 when Vi is less than 0. It is less than 0. Now the diode is ideal and diode is working in the forward biasing condition and it has been shorted. So like this, the diode is like this. So all the input, that means for this particular part of the waveform. Okay, so this particular part of the waveform, the diode is short circuit and this VO is equal to Vi here. So we will divide the question in two cases. When the diode is forward bias and when the diode is reverse bias. You have to understand that to find out the output. So there is no other thing in this particular circuit. So VO is equal to Vi. And finally what we do is we just draw the waveform like this. So this will be the output waveform. If you can see, this is the output waveform I am drawing. Here it is 0 and then it goes like this. So in this particular circuit, here the voltage is 0 volt and then VO is equal to Vi. So this is the output waveform and at x-axis it is at t. So this is how we can find out the output of this particular waveform. Similarly, there are so many questions where one more battery is also placed in the circuit. So here we can see the waveform is like positive half cycle and then it is going to the negative half cycle. One B battery is also being here established. Now this battery is what it is doing this to be, let's say it is making this particular diode as reversed bias, because this is the negative terminal and this is the P side of this diode and P side is connected to the negative terminal. So diode is in this case is being reversed biased by the battery. So this particular waveform will forward bias it, and this waveform when goes above V, then it will compensate the effect of the reverse biasing of V battery. So again I am telling this input waveform when it goes above the V voltage, then it just makes it positive bias, otherwise the diode remains in the negative region. So we have case 1 when input voltage is greater than equal to V voltage. So this particular part of the waveform, like here V and Vm. Okay, now the diode is short circuited like this and then R. So we will find out, we will apply this KVL Vi. So plus ka Vi minus V and is equal to VO. So output voltage will be Vi minus V, right? And let's say case 2. Well, case 2, when Vi is less than V, the diode is in the reverse mode and this particular part of the waveform. Okay, and here the output voltage is equal to 0 volt because there is no current, right? So we will draw the waveform. This is my output waveform. All the calculation have been done. It is very easy. You just need to find out the the cases. So output voltage, it is VO minus Vi minus V. That means the output here we can see VO is equal to Vi minus V. So let us draw the replica of this particular input waveform, and for this particular part, this will go here. Please understand, this is if Vm, then this part will be Vm minus V, and this part will go down here, this portion will go down here, and we will have 3 points, 1, 2, 3, and otherwise the waveform is, for rest of the part the waveform is shown like this. So final waveform which we are getting is, which I am drawing now, this is the final waveform. This point was V, so it will go down by this particular part, and hence we will get the waveform of the clipper, series clipper. This part of question can be done like this. That is the only thing. The trick is you need to find out, analyze the circuit, you need to find out the cases when the diode, your diode given in the circuit is reverse biased, and when your diode is given in the circuit is forward biased. Make the two cases, remake the circuit, apply Kirchhoff voltage law and get the output across the resistance, and then you can find out the waveform, output waveform, right? Similarly, we have biased series clipper. This question also can be done like this. So here this particular is reversing, it is forwarding, and this particular positive is making it in the reverse bias. So when this waveform at the positive side, it is making it reversed, and this particular is making it in forward direction. Then you have to find out what would be the output voltage across the resistance. When this diode, first of all you will analyze the circuit. Now you find out the cases when your diode is forward bias and when your diode is reverse bias. So make it is making it forward, but after V, when this Vm is greater than V, then this, for this particular part of the waveform, this diode, let's say here you can assume a value also 5 volt and this is 2 volt. This is making it forward, but this is making it reverse. So for this particular part, the diode will remain in the reverse bias condition, and for all rest part of the waveform, that means at this particular part and these two particular part, this diode will remain in the forward bias condition, because both the battery and the both input waveform will make it forward bias. Okay, this part the diode will be reversed, and for this the diode will be forward. You will make two cases and then you will remake the circuit and solve the question. So we have various different types of clipper circuit. As I told, you can have a look on this particular circuit. You can note down these questions, and there are various 6 types of clippers, and circuit has been shown in this particular diagram. Now you can note down, you can have a screenshot of this particular slide and do yourself, and then check your answers with here the answers are being given, and try to get all the waveform. Now we come to the parallel clipper simple circuit. Now here you can note down the output is being taken across the diode. If the output is being taken across the diode, that means we have a parallel clipper, as I told you before. So find out the cases when this particular is positive, then this diode is being forward biased, and when this particular is negative, this diode is being reverse biased. So make the two cases. As I tell you, always make cases. Case 1, when Vi is greater than 0, the diode is forward bias. This is short circuit. I am talking of this particular part of the waveform, plus minus. So output is here 0 volt, because the resistance is 0 for this particular these two terminals. So there would be no voltage. And case 2, when Vi is less than 0, okay, that means for this particular part of the input waveform, the diode is, forward bias, reverse bias, and output is equal to Vi. There would be no voltage across the resistance because it is, there is no current, so no voltage will appear here. All the input voltage will turn here. So we can make the output waveform VO, draw this output. For this particular part, this voltage is equal to 0 volt, otherwise VO is equal to Vi. In this way, we can make the diagrams of the particular circuit. So this is how we do. One more question we will do here. So we have just the example of biased parallel clipper. Here this diode is being reversed biased by this particular voltage, and this is making it forward. But this is making it reverse and this is making it forward. So when this voltage will reach up to the V voltage, then the diode will be forward biased. That means when this waveform will be greater than V, then for this particular part of the waveform, my diode will be forward bias. Otherwise, it will be reverse bias. So I have two cases now. Make the cases, it will make your question very easy. Case 1, when Vi is greater than V, then the circuit would be like, it is forward bias, make it forward. Here, Vi, and from this, Vo is equal to V. And case 2, when Vi is less than V, then the diode condition is, it is open, and here this particular is equal to Vo is equal to Vi. Here it will be, there will be no voltage. Now we will make, we will draw the input waveform. Make one, replica of the input waveform like this. Okay. So for this particular, we have Vo is equal to V, and otherwise it is like this. So this is my input waveform. This particular voltage is minus Vm and this particular voltage is V. So in this way we have again these 6 circuits. You can practice all these questions and you can solve all these. Take a note of this, make 2 cases, and then the process is find out where the diode is being forward biased and where the diode is being reverse biased, and then make the cases, case 1, case 2, make the circuit, and then apply the Kirchhoff voltage law, and then find out the answers for the 2 cases, case 1 and case 2, and draw the final output waveform. Thank you.